Let's kick off this explainer by completely rethinking everything we know about water. For generations, we've essentially treated water as a disposable commodity, right? Something we use once and just throw away. But today, we're looking at a massive paradigm shift. We are transforming water from a disposal problem into an absolute goldmine of a resource. And we're going to break down exactly how this works. To really grasp the stakes here, I want you to consider this wild statistic. Globally, 80% of our wastewater is not collected or treated appropriately. Think about that for a second. 80%. We are quite literally letting our most precious resource, along with all the valuable materials hidden inside it, just wash right down the drain.
Section 1, the broken water cycle. Let's take a quick look at why our current flawed linear approach is failing us under the intense pressures of climate change.
Now combine that 80% untreated waste figure with another stark reality. By 2030, global water demand is projected to exceed our supply capacity by a staggering 40%. Between aging infrastructure, devastating floods, and severe droughts, we're basically rushing headlong into a crisis where demand heavily outpaces what the Earth can naturally supply us. The root of the problem is our current linear economy. We take fresh water, we make it drinkable, we use it in our homes or industries, and then we just carelessly discharge it back into the environment. It's a one-way street. And honestly, it's a dead end. So we have to contrast that wasteful linear method with the circular economy, which is really the ultimate fix for balancing our water supply. Instead of that old take, make, use, and discharge routine, we're talking about reducing, reusing, recovering, and just being way more efficient. It's all about keeping water and its embedded resources in a continuous productive loop.
Which brings us to Section 2, the circular water framework, and how we actually go about building a resilient water future.
This transition is fascinating. By using advanced digital technologies and circular business models, we can actually turn traditional water utilities into smart, dynamic assets. Assets that actively regenerate our natural water basins, rather than just draining them dry. This entire framework leans heavily on these fundamental strategies. We've got to reduce water usage, guarantee the removal of hazardous pollutants, facilitate reuse and recycling, prioritize the recovery of valuable materials, and above all, completely rethink our relationship with the entire water cycle. When you put those strategies into action using smart management, you can seamlessly connect traditional gray infrastructure, like your standard pipes and concrete plants, with green, nature-based solutions. And when we integrate these properly, we can actually achieve zero-carbon water services. Let's move to Section 3, Advanced Treatment Technologies, because to make this circular vision a reality, we have to go far beyond standard filtration. First things first, before we can even talk about reusing water, we must tackle a major environmental threat: eutrophication. If we discharge wastewater that's packed with excess nitrogen and phosphorus, it triggers these massive algae blooms that literally suffocate aquatic life by eating up all the oxygen. So rigorously removing those harmful nutrients is step one. Now, how do we clean that organic matter out? We mainly rely on two biological workhorses. On one side, we have aerobic digestion, which relies on pumping air into the tanks. And on the other, we have the highly efficient anaerobic process, which works entirely without oxygen. The real game changer here is energy. Aerobic digestion requires massive amounts of electricity just to continuously blow bubbles into the water. But anaerobic digestion, it uses significantly less energy because it doesn't need all that aeration. Even better, the microorganisms naturally generate biogas, like methane, that can be captured and used to power the plant itself. All right, Section 4, Filtration and Disinfection. Once the heavy biological lifting is done, we have to polish that water so it's entirely safe for reuse. To do this, we map out exactly which technologies we need to capture specific microscopic particles. The operating ranges go from microfiltration, catching algae and bacteria, all the way down to reverse osmosis, which targets the absolute tiniest aqueous salts and viruses. To hit that absolute highest level of purity, we have to overcome what's called osmotic pressure. In reverse osmosis, we use high-powered pumps to forcefully push water through an incredibly fine membrane. The pure water makes it through, but the dissolved salts, sugars, and microorganisms get left completely behind. So the treatment flows logically, step by step, scaling down to microscopic levels. First, microfiltration clears up the cloudiness. Then ultrafiltration catches remaining bacteria and viruses. Finally, reverse osmosis acts as that ultimate barrier against dissolved salts, ensuring the reclaimed water meets incredibly strict quality standards.
The very last step is deactivating any remaining stealthy pathogens. We can use chlorine, which is cheap but requires careful handling so it doesn't harm aquatic life. We can use ozone, which is a fast-acting gas, or we can use UV radiation, which literally scrambles the DNA of viruses using light. No hazardous chemicals required. We just pick the method based entirely on how the water will be reused next.
Which leads perfectly into Section 5, Factories for Resource Recovery. This is the ultimate shift, and really the climax of our explainer. I want you to ask yourself, what if wastewater wasn't waste at all? Seriously, the water running down your drain at home or pouring out of industrial pipes is actually a liquid goldmine of raw materials just waiting to be harvested. Instead of just cleaning water, our utilities are evolving into actual resource recovery factories. They're extracting methane biogas for the power grid, capturing phosphorus and nitrogen for agricultural fertilizers, and reclaiming the water itself. For example, picture the incredible Nimra wetland oasis in the Oman desert. It's a 350-hectare constructed wetland that naturally cleans 115,000 cubic meters of highly toxic oilfield-produced wastewater every single day. They take toxic industrial waste, run it through nature-based filtration, and use that reclaimed water to grow salt-tolerant crops like cotton and acacia right there in the desert. That is the circular economy in pure action. And this builds a completely new commercial landscape. We are literally looking at a whole new economy built on reclaiming plant-based products, liquid fertilizers, critical raw materials, and clean energy right out of our urban and industrial water cycles. This paradigm shift is perfectly captured in this idea of utilities transforming into factories for materials, products, and services. We are no longer just managing a disposal problem. We are actively manufacturing sustainability. The future of water isn't just about desperately searching for new, pristine sources. It's about radically rethinking the value of the water already flowing through our pipes, our industries, and our communities. So I'll leave you with this provocative thought. Now that you know what's possible, how will this circular revolution change the way you personally value every single drop of water you use?